Assalamu alaikum students. My name is Mehmood Hussain. I am lecturer in biochemistry, Government Boys Degree College and Postgraduate Studies Center, Sukkur. Today I am recording this video for the students of first year pre-medical and first year pre-engineering who are studying first year chemistry book of Sindh textbook board, Jamshoro. Today I have selected a topic from the chapter number 7, that is balance the chemical equation by ion electron method. I think this would be more helpful for the students for the preparation of upcoming examination 2020. Before going into the detail for balancing the chemical equation, a student must know what is chemical equation, what is oxidation number, how to identify oxidation and reduction side of the equation, and how to balance the atoms and ions present in the equation. Chemical equation and oxidation number. Chemical equation is an symbolic representation of the chemicals present in the chemical reaction when they produce a product. Oxidation number. Oxidation number is an imaginary or the formal charge on an atom. It is not a real charge. It is under the concentration present in an ion or in a molecular form. Oxidation number of all the elements in its free state is always 0. In a compound, elements having more electronegativity have the negative oxidation number. The elements in a compound having less electronegativity have the positive oxidation number. In a neutral compound, sum of oxidation number is 0. The oxidation number of the oxygen in most of the compound is +2. The oxidation number of hydrogen when it combines with non-metal is +1. The oxidation number of the fluorine is always -1 because it is most electronegative element and cannot form more than one bond. In a polyatomic ions, the sum of all oxidation state of all the atoms present in them is equal to the ionic charge. The elements of group 1, 2 and 3 shows the oxidation number +1, +2 and +3 respectively. How to identify the oxidation and reduction side of the equation? I have indicated here 4 major points for the identification of oxidation and reduction side of the equation. A student must know that which side is oxidation side and which side is reduction side in an equation. Whenever there is addition of oxygen means the equation in oxidation. Removal of hydrogen, removal of electron and increase in oxidation number is also oxidation. And opposite of all these is reduction. Means the removal of oxygen is reduction, addition of hydrogen, addition of electron and a decrease in oxidation number is also reduction. Okay. Now how does the atoms present in an equation? A student must know that equation is going to balance is in an acidic medium or is in a basic medium. When it is in an acidic medium or in a neutral medium, student must balance hydrogen by H plus or hydrogen ions or proton we say, and oxygen will be balanced by the water molecule. This is only for the acidic medium. When our equation is in basic medium, you will replace a hydrogen by a water molecule and oxygen will be balanced with hydroxy ion. How to balance the charge? We have to balance the charge present in an equation by adding electrons. Here is a point to note for the student, that in case of the reduction of the equation, undoubtedly you have to add electron to the left hand side of the equation, and in case the oxidation of the equation, add the electron on the right hand side of the equation. Means you have to identify how you will identify the hands. You will identify when you are writing an equation, the right hand side portion of the equation is known as right hand side, and the left hand side of your left hand side portion is known as left hand side. Means the student often make a mistake here when they they add the electrons for balancing the charge. They forget this rule. Okay. And before going into the detail for balancing the chemical equation, a student must memorize these steps. You have to identify that equation is an acidic or in a basic medium. You have to identify that equation is in a molecular form or in a ionic form. You have to identify and separate the reduction and oxidation side of the equations. You have to balance the atoms as we have discussed earlier. You have to balance the electrons as we have discussed earlier. Now, you have to multiply the both side of the equation with an appropriate number to balance the electron on each side of the equation. Now add both part of the equation. After that, cut the same quantities present on the both sides of the equation. Finally, verify the both side, the number of atoms and the number of charges. And this we have an balanced equation. Let's suppose we have an example on the page number 225 of your textbook. You are given an equation to balance. That is, we have three compounds: potassium permanganate, potassium chloride and sulfuric acid. These three compounds are reactant and they are going to produce manganese sulfate, potassium sulfates, water molecule and a chlorine gas molecule. We have to balance this equation. Actually, the representation of the chemicals here in this equation are not the balanced on both sides. For balancing this equation, the step one is that it is in a molecular form. We have to write it in ionic form, and I have indicated here that the manganese oxide ion is going to form manganese, and a chlorine ion is going to make a chlorine molecule. And as we know that the reactant side sulfuric acid is present, so this equation is in an acidic medium. Step 2. We have to separate this into two portions. Means we have to identify the reduction and oxidation sides of the equation. We are observing that manganese oxide is going to make manganese. It means to say there is removal of oxygen. Means this is reduction side, okay. And here a chlorine ion is going to produce a chlorine molecule. Means this is oxidation side. Manganese oxide have the 4 oxygens, and on other side we do not have an oxygen. So we will add 4 oxygens on the manganese side, means the right hand side. And there is also a point that whenever you are going to balance the oxygen with water in an acidic condition, you will add also double number of hydrogens on reactant side. Double number of hydrogen means to say, when you are going to add 4 water molecules, it means you are going to add 8 hydrogens on that side. To overcome those 8 hydrogens, you have to add 8 protons on the reactant side. So in the second step, chlorine ion is going to produce chlorine molecule. It means we have to add another chlorine ion. So 2 chlorine ions are going to produce chlorine molecules, means the oxidation side. Step 4. Now we are going to balance the charge on both sides by adding electron. As I have discussed earlier, that manganese oxide is going to make manganese. Here 2 positive charges on the product side, and here 8 positive charges on the reactant side and 1 negative charge. To balance these charges means we should have 2 positive charges on each side. We have to add 5 electrons. Second portion of the equation. Reactant side, 2 ions are present, 2 charges are present, negative charges. So on other hand side, we have to add 2 electrons to balance those 2 negative charges. Now we have to multiply our equation with an appropriate number. That appropriate number definitely could be 2 and 5. Why? When we will multiply both opposite sides with 2 and 5, we will have the same number of electrons on each side of the equation. It will be 2 manganese oxide, 16 H plus and 10 electrons on reactant side. 2 manganese and 8 water molecules on right hand side. Second portion of the equation, 10 chlorine ions, 5 chlorine ion reactant side and 5 chlorine molecules and 10 electrons on reactant product side. Now we will add both sides of the equation. When we will add both sides of the equation, we will have 2 manganese oxide, 16 H plus, 10 electrons and 10 chlorine ions. 2 manganese ions, 8 water molecules, 5 chlorines and 10 electrons on the product side. Step. We have to balance the both sides by cutting the same quantities. Here we are observing that the 10 electrons on each side are the same. So we will cut it. After that, we will have 2 manganese oxide, 10 chlorines, 16 positive charges, means 16 H plus, and they are going to produce 2 manganese, 8 water molecules and 5 chlorine molecules. Now, in final, we will put this equation into the first one. Then we will have 2 potassium permanganates, 10 potassium chloride, 8 sulfuric acid molecules. These compounds will produce 2 magnesium sulfate, 6 potassium sulfate, 8 water molecules and 5 chlorines, molecule chlorine gas. Now we have a balanced equation. Finally, we will verify the both sides of the equation, means the number of atoms and the number of charges on both sides of the equation. Just consider over this one. 2 manganese oxide and 10 chlorines means 2 negative charges of manganese oxide and 10 negative charges of 10 chlorine ions, means 12 negative charges here we have and 16 positive charges of H plus. It means we have total 4 positive charges on this side, means reactant side. On the other hand side we have 2 into 2 means the 4 positive charges of the manganese. It means on the both hand side of the equation we have 4 positive charges, means the charges are balanced. Now atoms, 12 potassium atoms means 2 atoms of potassium permanganate, 10 potassium atoms of potassium chloride, means total potassium 12 potassium we have, 2 manganese we have, and by calculating we have 40 oxygens, 10 chlorides, 16 hydrogens, 8 sulfur atoms on each side, means our atoms are balanced. Now we have an balanced equation. In last, I am thankful to all, I will say thanks to all. I am thankful to all the authorities for providing a facility for the students and for us in these days. I am thankful to all the students who are giving maximum time to their studies during these days. And I suggest all the students to solve more examples present in the book until you become able to solve such equations easily and getting full benefits of these video classes programmed by the government of Sindh. Thanks for watching.